In this video, we're going to talk about the key features of cosine and also what makes cosine and sine different, or just similar. Let's start with sine and cosine being similar. And what a lot of students said is that if I'm going to let's do similarities, similar, different. And this is cosine. What a lot of students notice is, well, the domain's going to stay the same because it goes on forever in the negative direction. Let me pull that up. And it also goes forever in the positive direction. So the domain is going to be negative infinity to infinity. And this, I should clarify that as well. The reason that's going to be the case is, first off, well, let me go through. I'm like, well, let me go through it first, and then I'll tie it all together. Domain is negative infinity to infinity. Similar thing is another thing. Another similar thing. Gosh, I can't talk today. Is the range. So the range is going to be -1 to 1. It does touch at -1. It does touch at +1. So that's going to be similar to the sine function. The amplitude stayed the same. So this distance there, from the middle of the function to the top, that's 1. From the middle of the function to the bottom, that's also 1. So our amplitude stays the same as 1. And our period stays the same as well. To give you a glimpse of why that is, if we start here at 0, 1, if I trace the function, I'm going down, go into -1, come back up, I'm back at 1, and then it repeats that action. Where does it repeat? 2 pi. So that's why the period is 2 pi. Now I want to talk about what I was going to try to say earlier. The period is 2 pi. Where is that coming from? Well, in class we talked about what is that related to. Think about this. If you're starting here on the circle and go all the way around the unicircle, that's 2 pi. So here, I start here and go around the unicircle. This is taking all the cosine values around the entire unicircle. Now, as I continue going, I can keep going. And what's happening here is I continue going. What it's doing is it's taking into consideration every single coterminal angle with these guys. So if I go all around, I'm at 4 pi. So I go back down, up, and back to 1 at 4 pi, down, up, back to 1 at 6 pi, and so on. And so you get the idea is that what's happening here is that as this continues to go up and down because it's taking care of every single coterminal angle that this function could ever have, which is why the period is 2 pi, and also the domain would be negative infinity to infinity. Whew. All right, differences. So the biggest difference that people talked about was here, cosine starts. It never really starts or ends, but it does start, quote unquote, at, nope, I cannot get cosine right. Sine I'm all good on. Cosine starts at 0, 1. So our sine function started at the origin. Cosine starts at 0, 1, goes down and then up. Sine starts at the origin, goes up and then down. So those are the main differences here. This piece here is going to be huge because that's going to actually help us graph the sine and cosine functions and differentiate between the two. If we're dealing with sine, then we know we're going to start with the origin, go up, down, back up. If we're dealing with cosine, then we know we're going to start at 0, 1, quote unquote, go down, up, and then it's going to continue with that pattern. So notice here, the similarities, the domain range, it's going on forever in both directions. Its lowest value is -1, its highest value is 1. The amplitude stayed the same, the period stayed the same. There's very similar functions, but almost shifted, if you will. And we're going to explore that more in the coming weeks. If you have questions, please feel free to ask me. We also did something else in class, but it's going to be really hard to describe what we did through a video. But if you're in class on what's now Tuesday, September 5th, Wednesday, September 6th, then we'll explore that more and be able to talk about what we did in class then. Again, if you have questions, please feel free to email me, remind, or you can ask me in class. That's fine as well.